All right, standard 4 for quarter 3. This one's gonna take a minute because we gotta do a table and a tree. Let's look at it here. So a probability table for flipping a coin and rolling a 6-sided die. When you make a probability table, you need to show the outcomes for your 2 events on each side of the table. So I'm gonna make a table that is longer this way because I left myself more room that way. To do that, on the left side, this is going to be the coin flip. And when I flip the coin, my possible outcomes are heads and tails. On the top, I'm gonna have my outcomes for the die. So this is the die, and the possible outcomes for rolling the die are going to be 1, 2, 3, 4, 5, and 6. And of course, it doesn't matter. If you do this table reversed where the die is this way and the heads and tails are on the top, that's fine. The insides here are the combinations. So, you know, I didn't really make myself a big enough table, and that's okay. But what we would see here is this one right here would be getting a heads and a 1. This one right here is a 2 and a heads. So heads and 2, heads and 3, heads and 4. I'm using the grid on my paper to represent the squares in the inside here. So each of these is their own square. And below that, these are all tails and 1, tails and 2, tails and 3, tails and 4, tails and 5, and tails and 6. So that's your table. Sorry, I did it kind of tiny. I didn't mean for it to be so tiny, but hopefully that helps. Here is the probability of heads and even. So if I want to find the probability of getting heads and even, I look how many outcomes did I have total? Well, there are 12 squares inside of this table, so that's my denominator. How many times did I get a heads and an even number? Well, here's heads. I got a heads and a 2, a heads and a 4, and a heads and a 6. So 3 times out of 12. And of course, you can divide these both by 3 and tell me that it is 1 out of 4 times. So a quarter of the time, you will get a heads and an even number. All right, let's jump over to I'm on another page here, number 12. There's some writing on the back of this, so I don't want you to have to see through the page there. So a probability tree for spinning 3 times this spinner here. I didn't color it. I went ahead and just wrote B, R, and Y for blue, red, and yellow. And that's what I'm gonna do here in my tree. So every time I spin the spinner, I have 3 possible outcomes, blue, yellow, and red. And to show that in my tree, I'm going to show 3 branches. So to start, you can get, I actually like to do an original line here. So blue, let's say yellow, and red. Does it matter what order you do these in? No, it does not. Just make that look more like an R. All right. That represents the first time that you spin the spinner. Now, you've gotten one of these results. The second time you spin the spinner, you could get all 3 of these again. So off of each of these options, you have to do 3 branches. That's how we show multiple spins. Blue, yellow, red. I suggest you keep them in the same order that you did them over here. For your viewer's sake, which is usually me, but also for your own sake. So look at what we have here. We have our first spin is represented by blue, yellow, and red over here. My second spin outcomes are here. So what these represent, like this blue, represents getting blue and then blue. This yellow represents blue and then yellow. This red down here is red and then red, while this red right here is yellow and then red. So we look at the end column here for the combinations. But this is only 2 spins, we need a 3rd spin. So off of each of these, we're gonna need to again do all 3 outcomes. And this is where it always gets a little messy, and that's okay. So blue, yellow, red. Blue, yellow, red. Blue, yellow, and red. And again, I have to do it again. I know this is a little tedious. That's okay. Just off of each of these, I'm doing blue, yellow, and red. Of course, it always gets squeezed together here because it is hard to space them. I totally understand. I am yet to do a perfect one in all my years of teaching this. Oof, sorry that's a little messy, but let's look at what we've shown. We've shown the first spin, 3 outcomes, blue, yellow, and red. Then off of each of those, the 3 outcomes for the second spin. And then off of each of those, we've again shown the 3 outcomes. So for my final combinations, we're going to look at these last numbers. So if I want to get this B here, that's blue, blue, blue. This Y is blue, blue, and yellow. Let's say this yellow is yellow, blue, and yellow, and so on there. How many total combinations do we have? Well, we look at this column. If we were to count all of these, you would count 27. There are 27 total combinations. We don't count these ones because these are only the first and second spins. We're only looking at the outcomes from all 3 spins. So this wasn't actually part of the question, but there are 27 total combinations. And that's going to help us when we slide down here to number 13, where it says, what's the probability of getting at least 1 yellow? Well, we know there's 27 total combinations, so that's my denominator. Let's count all the times I got at least 1 yellow. You got to do this systematically, so you got to go down the list. So this one, blue, 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 no. Here that has 1 yellow, so that's 1. Nothing. There's 1 right there, so that's 2, 3, 4. Because those all had this one right here. No. 5. No. Now these are all have a yellow in the beginning, right? So every one of these is going to have at least 1 yellow. So I was at 5, so 6, 7, 8, 9, 10, 11, 12, 13, 14. I come down here. That one has a yellow, so that's 15. These 3 all have this yellow right here, so that's 16, 17, and 18. And then this one right here has a yellow, so that's 19. So 19 out of 27. I hope I counted that right. Yes, I'm looking at my key. It was 19 out of 27. There's another way you can do this, though, which I don't know if it's necessarily that much easier. But if we're looking for the probability of at least 1 yellow, you could find all the times that you don't have any yellow and then subtract that from 1. So the other way you could do this is count the ones where we don't have any yellow. So 1, 2, those all have at least 1. 3, 4. These all have a yellow. 5, 6, those all have yellow. 7, 8. And if I subtract 8 from 27, I get 19 over 27. So that's another way you can think about it, is figure out how many times you don't have any yellow and then subtract that. All right, there is standard form.